Alright, so this is your arithmetic sequences and series quiz. Alright, so we're given the following sequence and we want to find the 57th term. Alright, so the formula we're going to use for this is a sub m equals a sub n plus m minus n times d. Alright, now m is the term we're looking for, so we're looking for the 57th term. Equals a sub n. You can pick any of these three for a sub n, it doesn't matter. Alright, so for a sub n, let's do 21. Plus, now since we picked 21, 21 is the first term, so n is 1. M is 57, remember. And n, since we picked the first term, is 1. So minus 1 times our difference. So what are we doing? We're subtracting 2. So our difference is negative 2. Alright, so there we go. So equals 21 plus 56, times negative 2. So a sub 57, after you finish your calculator work, is negative 91. Alright, so the 57th term is negative 91. Alright, let's go on to number 2. Number 2 says, consider the partially completed arithmetic series. And then we need to fill in the blanks. So what you need to do is you need to take the last term you have, which is negative 13, subtract from it the first term you have. So this is negative 36. Now what you want to do is count the number of hops. 1, 2, 3. So it's 3 hops from this term to this term. So we're going to take that negative 36 and divide it by 3, and that will give us negative 12. So in this case, D equals negative 12. Alright? Now, let's fill in these other numbers. So most of y'all are just going to add 12 to get this number and then subtract to get these numbers. But say instead of this being our, 5th and 7th term, whatever, say we needed another term. Say we had other terms and we wanted to fill them in. So the formula you'd want to use would be this a sub m formula right here. Alright, because we know this is our second term, so we're looking for a sub 1. And we have our second term, 23, plus that is our second term, minus we're looking for our first term times our difference of negative 12. So this would be 23 plus 2 minus 1 is 2 times negative 12. Right, 2 minus 1 is 1 times negative 12. Alright, so this is simply going to be this is backwards. Wow, I'm messing this one all up. So it's negative. So this is simply going to be 23 plus 12, which is 35. Okay? The reason I did it this way is because it might not be nice. You might have other terms and need to find your first term. So you need to know how to work this formula. Alright? Because as you can see, if you just add 12, you still get it. Alright? So now for the rest of them, I'm just going to subtract 12 from 23 and get 11. And then that's negative 1. Alright? But remember your formula, a sub m, m is the number you're looking for. We're looking for the first term, equals 23 plus n, which is the number of term you're looking for, which is 1, minus the term you used here, so we used our second term, times your difference. That's negative 1 times negative 12, which is positive 12, plus 23, which is 35 for the first term. Subtract 12, 11, subtract 12, negative 1, subtract again, negative 13. Alright? Moving on. Number 3, consider 19, 13, 7, and so on. What is the 100th term? So again, we're going to use this formula. A sub 100 equals, let's use 19, that's our first term, plus we're looking for a 100th term minus our first term And our difference, it looks like we're subtracting 6. All right? So this is going to equal 19 plus 99 times negative 6. So plug it into your calculator. Your 100 term is negative 575. All right? Your 100 term is simply negative 575. All right? So again, it's just plugging into this formula, knowing what M and M stand for. M is the term you're looking for. N is the number of term you've used over here. So N, if you use the 19, 19 is the first term, so N is 1, and A sub N is 19. And this would be 100 minus 1, and then of course your difference. All right? Number 4. What is the third term? The third term in an arithmetic sequence is 23. The 78th term in an arithmetic sequence is 173. What are the first 5 terms of the sequence? So what you want to do, you want to figure out the difference. So 173 minus 23 is 150. And then 78 minus 3 is 75. So the 75 is your number of hops, and this is your overall difference. So to find your difference between two of the terms, you're going to take the 150 and divide it by the 75 hops to get 2. So in this case, our difference equals 2. All right, so you subtract the numbers, subtract the number of term, so 150 and 75, and then divide the overall difference by the number of hops to get your actual difference. All right, so now that we have that, we can simply find our first term. So A sub 1 equals 23 plus M, we're looking for our first term, minus 3 times our difference, which is 2. So A sub 1 equals 23 plus negative 2 times 2. So A sub 1 equals 23 minus 4. A sub 1 equals 19. So now we have our first term, 19, and we know our difference is 2. So 19 plus 2 is 21, plus 2 is 23, plus 2 is 25, plus 2 is 27. And there's our first 5 terms. All right? Yes, you could have simply, since you know your difference is 2, you could have simply said 23 minus 2 is 21, minus 2 is 19, and then added 2 in the other direction until you got 5 terms. But again, what if they only gave you, say, the 10th term and the 78th term? Then that wouldn't be as convenient nor as fast. All right? Number 5. So we have a sum here. We have j equals 1 to 62, and then we have negative 2 plus 5j. So now we want to find the sum. So we're going to use our sum formula, and our sum formula is a sub 1 plus a sub n times your number of terms over 2. All right? So we need to find our first term. Plug in the 1. All right, so a sub 1 equals negative 2 plus 5 times 1, which is just negative 2 plus 5, which is 3. So a sub 1 is 3. Now we need to find our last term. A sub n is your last term. Okay, last term. All right, so plug in the 62 to find your last term. So a sub 62 is going to be negative 2 plus 5 times 62. All right, so 5 times 62, and then minus 2 gives you 308. So now we have these two, so our sum equals 3 plus 308 times our number of terms divided by 2. Well, how do you figure out the number of terms? If you remember, when I said this starts with 1, this is your number of terms. So we have 62 terms. So S equals 311 times 31, which comes out to be 96 41. And that is your final answer. 9,641. That is the sum of this series. All right? So remember, we used our sum formula. Once we found our first and our last term, and all we did was substitute in for the j, substituted into 1 to get the first term, substituted into 62 to get the last term. Then we plugged those two numbers into our sum formula. 3 plus 308 equals our number of terms. Remember, when this starts at 1, this is your number of terms. So 3 plus 308 times 62 over 2. So 311 times 31 is 9641. All right. Number 6 works similar. Actually, it works the same way, just different numbers. So I'm going to do 6 just a little faster. All right. We have k equals 0. 63 of negative 3 plus 5k. All right. So find the first term. And that is simply you plug in the 0, that's gone. First term is negative 3. Let's find our last term, a sub 63. Negative 3 plus 5 times 63. All right, so a sub 63 equals 312. Now we're going to plug into the sum formula. Negative 3 plus 312 times 63 minus 0 is 63 plus 1 is 64 over 2. Because remember, if this is anything other than 1, take the top, subtract the bottom. 63 minus 0 is 63. Add 1 is 64. That is your total number of terms. Now this 64 is not getting plugged into here. The only place the 64 is going is above the 2. All right. So S equals, when you do out all the math, you get 9,888. All right. Like I said, that works just like the previous one. Number 7, what's the sum of the first 71 positive even integers? So we're going to use this formula here to find our last term because we know our first term. Our first term is 2 because we're finding the sum of the first 71 even positive integers. This is your first even positive integer. All right, so now we want to find our last term. Well, that's our 71st term. All right, because remember, it's 71 terms. It's not saying from 2 to 71. It's the first 71 even positive numbers. All right, so a sub 71 equals a sub n, which is, we're going to use a sub 1 because we know it, which is 2, plus, we're looking for 71 minus our first term. And we know our difference is 2 because you can take any two even numbers, like 4 is our second one. 4 minus 2 is 2, so we know our difference is 2. All right, so a sub 71 equals 2 plus 70, times 2, which is 2 plus 140. So a sub 71 is 142. All right, so now we have our first term, we have our last term, we know our number of terms, so now just plug into the sum formula. So our sum equals our first term, 2, plus our last term, 142, times half our number of terms, so 71 over 2. All right. Plug this into your calculator, and you get 5112. All right, 5,112 is your sum. All right, so the first 71 even numbers equals quite a lot if you look at it. All right, it actually equals quite a lot. Who would have thought it would have been that high? And the last one. The last one is just like number 7. It's just a word problem, which I think is what throws some of y'all off. All right, we know there's 24 rows, so that means our number of terms is 24. All right, we know our first term is 1 because it says there's 1 can on the topmost row. So we know our first term is 1. We also know that our difference is 7 because it says as you go down you add 7 cans. All right, so what are we going to do? Well, first we need to find our last term, and then we can use our sum formula. So we know there's 24 terms, so a sub 24 equals a sub n, which is 1, because it's the only term we know right now, plus we're looking for our 24th term. We're using our first term, and our difference is 7. So a sub 24 equals 1 plus 23 times 7. So our 24th term is 162. So now we have our first term and our last term. Plug it into the sum formula. Sum equals first term 1 plus 162 times 24 over 2. So S equals 163 times 12. So S equals 1956. All right, 1956. Okay, so again, this is just, the word problem is just a simple, you have your number of terms, you have your first term, you have your difference, so you plug into A sub m to find your 24th term, and then once you have your first and your last term, you simply plug those into the sum formula and come up with your sum. All right? So this has been your arithmetic sequences and series quiz review. You can watch this as many times as you need to. Make sure you come tomorrow ready to take it. See you tomorrow.